All right, good morning. Welcome back to Calculus 1. We are going for pretest 2, problem number 3a, and these are just a couple of hyperbolic derivatives. Excuse me, I gotta ask just to make sure you're memorizing all of your different derivatives so that when you get to Calculus 2, you can do this all backwards and you won't have to deal with what's going on. Okay, so make your little index cards, your 3 by 5 cards, and memorize what your derivatives are going to be. So this is just going to be a pretty standard derivative. So we're just going to say derivative of this. So the derivative of hyperbolic tangent is hyperbolic secant squared. And then here, we've got a product rule. So we want derivative of the first times the second plus the first times the derivative of the second. Tick. Okay, so I just laid out the plan here. So we're just going to go ahead and say we have secant, hyperbolic secant squared, plus taking the derivative of x squared gives me 2x, and then we have hyperbolic cosecant, okay, and then plus x, and then the derivative of hyperbolic cosecant is going to be negative hyperbolic cosecant, hyperbolic cotangent x, okay, I believe that's what we have for that one. So we're going to go ahead and say, well, that's what we have. Okay, so we're going to say this is simplifying this down. There's not much simplifying to do. I wouldn't expect people to like go through the trigonometric stuff and see, like, can I combine all this stuff? I'm like, no. So plus 2x hyperbolic cosecant, and then minus, we have, it looks like an x. Yeah. Oh, no, there's an x squared here. Derivative of the second. X squared, and this was where this negative sign came down to, and then we just have cosecant, hyperbolic cosecant, hyperbolic cotangent, and I wouldn't worry about like trying to get common denominators or do anything with any of this because it's just going to be a mess. This is going to be whatever cosines, this is going to be whatever sines. It's not really going to do what you think it's going to do. Okay, so we're just kind of stuck with that and we'll call it there. We'll say, okay, that's a good derivative. Again, I'm sorry for asking a question like that, but we got to ask for the sake of asking hyperbolic derivatives. Okay, so there's my attempt at making you guys do this. Okay, nothing tricky, pretty standard. Just make sure you memorize all your derivatives for things, and you'll be set to go. All right, thank you. Good luck.